Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with episode number 20 in our incredible new tutorial series where you're going to learn Python or you're going to die trying. I'm going to need you to pour yourself a nice strong cup of coffee. That is straight black coffee, hot, no sugar, no sweeteners, none needed. Why? Because you guys watching this channel, you're jet fighter aircraft. And what does a jet fighter aircraft need? Needs its jet fuel. Go get you some. I am also going to need you to go ahead and fire up your most excellent Visual Studio Code. And as you're firing up Visual Studio Code, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. We are going to learn about how to do threading, threads and threading in Python. And actually, this is a pretty important thing for the direction that we're going to be going with these future lessons. And kind of to review a little bit, what did we learn about last week? We learned about how to do classes and methods, okay? How to use classes and methods. And hopefully that lesson made sense to you. And then today we're going to learn another very, very important concept that it's a little bit kind of associated with classes and methods. It's kind of an advanced Python technique, and it is called threading, okay? What is the problem that we have with computer programming? Computer program executes one line of code at a time, and it doesn't move to the next line until it finishes this line. And so it goes down the page line by line by line, and it does one thing at once. Okay. Why is this a problem? Well, imagine that we start working with some sensors and start working with, maybe we're talking to Arduino as we're trying to draw a graph, as we're trying to do this different stuff. And all of a sudden, it doesn't work to do one thing at a time. You've got to do more than one thing at a time. All right. And I'm going to show you how to do that today. But I think the instructional material out there on threading is really, really complicated, and they just start banging it out like you already know what they're doing. And so I'm going to give you a very simple problem, and that very simple problem is going to illustrate the need for threading. Okay. And so now I am going to switch over to my Visual Studio Code. I'm going to get me a little Go juice here. All right, so I will get out of your way, and let's just start with some relatively simple concepts. So I am going to come up here, and we are going to go to our Python files folder. I'm going to create a new file, and then I am going to call this thread example.py. The .py is pretty important, and boom, we've got ourselves a fresh new Python program that is just waiting to be written. It is just waiting to be written. So let's imagine that we have a box, okay, and that box is gonna, what we want to do is we want to open the box, and then we want to, like, let's say, leave it open for 5 seconds, and then we want to close the box, and we want to leave it closed for 5 seconds, and then open the box, and then close the box. Also, the box, it has a little LED inside of it, and that LED can be on or it can be off. So the box is opening and closing. We're going to want to do that, and then we're going to be turning the LED on and the LED off. All right, so let's just kind of play around with this, and let's say that we're just going to do the open and close business first. And so what I could say is I could do something really simple, like I'm going to need to be doing timing, right? I'm going to be needing to put some delays in here. So I need to import a library that allows me to put delays in. So I'm going to say import the time library, or I'm going to do this a little bit different, from time import star, from time import star. What that just means is go to the time library and import everything out of the time library. So sometimes there's little sub libraries in the library and you can just grab one. We're going to grab everything. All right, and so now what we are going to do is we are going to say print, and we are going to print my box is open. Okay, and now what do we want to do? We want to wait. So I'm going to say sleep for 5 seconds. All right, then what I want to do, I want to close the box. So I'm going to print my box is closed, like that. All right, now this should be a fairly simple thing to run, and so let's just hop over here and let's run this thing. Okay, it's pretty obvious. So you open the box, my box is open, it waits 5 seconds, and then it says my box is closed. All right, and I'm realizing that if we want to keep doing this, this needs to be like, let's say, inside of a while loop. So I am going to say while, and then while true. When is true? True. True is always true. So I've created a what? I've created an old infinite loop, and then I need to tab this stuff over so it'll be inside of there. So now this should just open the box, close the box. Now, of course, in a real program, you would like give it a command, like maybe you would send a command to a servo that would open the box, and then you would wait 5 seconds, and then you would send a command to close the box. All right, so you would open the box and close the box, and my goodness, we need to sleep again 5 after that. So where I'm just saying print, just imagine that it's a command to move the servo to open it. Well, then you want to wait 5 seconds, and then you want to move the servo to close it, right? So this is very simple, but it is showing you what is going to be the problem. So look down here, boom, my box is open. We're going to get a little go juice here. My box is closed. Very poor formatting there. Let me fix that. Kill this. You get the idea of what we're doing, though, don't you? Okay, my box is open. Wait 5 seconds. My box is closed, looking good. My box is open, and then my box is closed. Okay, so we're sitting there and we're opening the box and closing the box and opening the box and closing the box. But remember, we also have an LED, and we want to be blinking that LED. Okay, and so we want to blink that LED, and let's say we want to have it on for a second and off for a second. Well, if I just came down here and said print, if I just came down here and said print, oh man, this is annoying me. I'm going to turn that auto complete off one of these days, and it's going to make you guys happy because it's not going to be covering things up. So then I could say like print my LED is on, and then I could come down here, and then I could sleep for 1, and then I could say print my LED is off, and then I could sleep for 1. All right, now what is the problem with this? Well, I'm going to open the box and wait 5, and close the box and wait 5, and then turn the LED on. So the box is going to be open, and then it's going to be closed, and then finally I'm going to turn the LED on and off, and then that gets this on. You see, what do I want? I want to turn the LED on right here, okay, but I can't turn it on here because then it would stay on for 5 seconds. So you see, once you hit one of these sleeps or one of these delays, that sits at that line of code. And so while I am sitting here waiting to leave that box open for 5 seconds, my code is locked up here on the sleep 5, and I can't be turning the LED on and off over here because the whole program, the whole enchilada has locked up on this one thing. And so this shows you the problem with programming. You operate, or you execute one line of code at a time, and it stays at that line of code until it's ready to go to the next line. Does that kind of show you what my problem is? Okay, well, this is where threading comes in, and what we are going to do is you launch a thread, and that thread is operating independent of this thread. So I have one thread that is opening and closing the box, and then this other thread acts like a whole different program that's turning the light on and off. Okay, so we're going to create multiple threads and they don't interfere with each other. Well, to do something like that, what we're probably going to need to do is just start by writing some functions, because you can imagine that you have a function that does one thing, you have a function that does another thing. Now we got to run both functions at the same time. So let's kind of rewrite this with functions. We're still going to need our old friend Mr. Time, old man Time. We're going to need him, and we're also going to need threading. So from threading, import, we just need one thing, and that is uppercase THREAD. Make sure you see that threading here is lowercase and thread here is uppercase. So we are going to import those two things. Now I need to define two different functions. The first function is going to be my box, all right, like that. And then what does my box do? Well, I'm going to print I'm going to print my box is open, and then what do I want to do? I want to sleep for 5 seconds, and then I want to print. I want to print my box is closed, and then what do I want to do? I want to sleep for 5, like that. Right, so this will just do what I was trying to do earlier, but now I'm going to make another function, and it's a function because it's not inside of a class, right? If it's inside of a class, it's a method. This is not in a class, so then I will say def my LED, like that, and then what is this going to do? I'm going to say print my LED is on. And then I'm going to sleep 1, because what I want to show you is I got one thing that's going really slow, and then I've got another thing that's going faster. And then I'm going to say print my LED is off, and then sleep 1, like that. So now I've got two functions. Now if I just was down here, and said my box, like that, that should work, right? Okay. I also remember one other thing that's kind of important is once I come in here, if I did it this way, it's just going to open it and close it. And then my LED would turn it on and turn it off. But I really want these things to keep going, right? So I'm going to put it in a while loop. I'm just going to say while true. When is true? True. True is always true. And so this then, with what I have done, is going to make this an infinite loop. And then I will do the same thing here. Got to indent these so they will be inside of a while loop. And I'll say while true. Okay, now what's the problem? If I call my box, it's just going to sit and run forever, right? So let's try that. My box is open. My box is closed. Okay, what's the problem now? It's just going to sit there forever in an infinite loop, and I could never even call my LED to turn it on and off because it's completely locked up in an infinite loop there. So again, this is where what we need to do is fire off one of those functions and then fire off the other one and have them running in separate threads. Okay, so we have imported the threading library, and we have these two functions defined. And so what we need to do is we need to set up some threads. Now this isn't starting the thread, this is just setting up the thread. So I'm going to set up the thread by saying I'm going to have a box thread, and that is going to be equal to thread uppercase T Okay, now understand this box thread, you can call that whatever you want. You're kind of creating a thread and you're giving it a name. The name is box thread. It should be something probably related to your box. So thread. And now we're creating a thread, and what do we want to target? We want to target the function myBox. All right, target the function myBox like that. And then I think that should work. And now what I want to do is, you guessed it, I want to have an LED thread, and that is going to be equal to thread, and then the target equals, man, I messed up here, didn't I? It should be target equals myBox, and then target equals my LED. All right, so this is saying that you want to run this myBox function. You want to run it as a thread, and you're going to call that thread box thread. And you're going to want to run myLED, that function, as a thread. You're going to call it LED thread. So I have those two things hooked up, started. Now, one thing is that if you're not careful, you could have a program, and then you could have a thread, and then you kill the program, and you end up with those threads out there kind of existing in the nether world. And so you want to kind of, when you kill the main program, you want it to kind of kill the threads that were spawned. And so if I understand right, I would do that by setting box thread dot daemon equals true, and then LED thread dot daemon is equal to true. And this is just setting it up that when you kill things, it should kind of kill all the things and not ending up with random processes out there going. And so now let's see if we can do this. We are going to say box thread dot start. Box thread, that would not work well. Box thread dot start, like that. And now what do we want to do? LED thread dot start. All right, now we're almost there, but what you got to see here is if I started this, it's going to come up in an infinite loop in a separate thread, and then it would start this one up here in an infinite loop in a separate thread. But immediately after that, what's going to happen? Python is going to come here to this step, and there's no step there, so what's going to happen? It's going to be the end of the program. The program is going to end, and since we set those two daemons up, what's it's going to do? It's going to kill our thread and kill our thread, so we need to just pause here. So the easiest way to do that is just to say while true. When is true? True. True is always true. What do you want to do? Absolutely nothing. And so we're just going to pass. And so the program's going to be sitting here and not ending. And then up at the top, what's going to be happening is those things are going to be running in separate threads. Could I have really done this without messing something up? It's really kind of clear, isn't it, if I show it to you nice and easy like this? Okay, let's see what happens. We're going to go ahead and try to run this thing. My box is open. Okay, guys, look at this. Look at this. Boom. Look at this, okay? You say the box is closed, and then LED is off, on, off, and then box is open, and then on, off, and box is closed. Boom. Look at this. We're threading. Who's your huckleberry? I'm your huckleberry. Do you see this? Look at that. We are running this thing in threading. Okay, I'm going to make it a little easier to look at because it was kind of hard. So what I'm going to do is I'm going to kind of put a big indent like this and a big indent like this. And so it'll be easy to see the difference between my box is open and my box is closed. This is going to be a lot easier to see. So let's run this thing. Okay, my box is open, and then on, off, and then box is closed, and then off, on. And you see from here on to off, this is still working even though this is coming in and interrupting it. Boom! Do you see that? Look at that. We are running threads. Now, what I bet is, I bet the main program is still going to be its own separate thread. And so let's just do something here. This is just to kind of play around with it a little bit. What if I came in here and on this while true, let's just say I said j is equal to 0. And then what I could say here is I could say print j. All right. And then what I could do is I could say j equal j plus 1. So I'm just going to put a simple counter. And then what I'm going to say is sleep 0.1. Let's see if you could actually do that inside of these other ones. And let's see if that'll work. All right, so let's run this thing. Okay, look at that. So you look at that, boom. Okay, so you see the LED is on and the LED is off. And so that counting is not messing up the LED on and the LED off. And then what you can see is that my box is open and my box is closed. So what you can see here is that now your Python program is kind of its own thread. And then I have the my box thread and I have the my LED thread. And so I kind of got three things that I'm juggling all at the same time. And it looks like it is really working. Okay, now a couple of things. I did this as simple as possible so that it would be easy for you to understand. But what you can also see is really you might need to pass a parameter up here because you might need to give it like some data. And so how would I pass the parameters? Because when I am calling it, I am just saying target my box and target my LED. Well, you might think you would do something like put in delay T, like delay T, where you passed it a parameter. And if you thought that, you would be wrong. If you thought that, you would be wrong. And this is the way you have to do it. So we're going to come up here, and what we're going to want is we're going to want a delay time. And so the parameter that you want is delay T. And then what you are going to do is, you guys can see that. Okay, I'm going to get this. And then I'm going to put it in delay T, and then I'm going to put it in delay T. And then here I'm going to have, I'll just give it a different name, delay, I'll just give it the same one, delay T. And then here, and when I call it, I can make it different, right? Okay, when I call it, I can give it a different variable. All right, so now how do I call it to pass that delay T? And so I'm going to say delay box is equal to 5, and then I am going to say delay LED is equal to 1. And then here, what I've got to do is I've got to come up and I've got to give it a comma, and then I've got to get out of your way all the way. Okay, so I give it a comma, and then I've got to say args for arguments equal, and then I got to pass it the arguments. And this argument that I am going to pass it up here is going to be delay box right, delay box. And now this is the darndest thing, if I understand this right. If you only have one argument, you got to put a comma after it. Now, isn't that crazy? That is really crazy. Let's see if it says. Okay, and now I'm going to have to pass the args here, which args are going to be equal to, and then this is delay LED, and then comma, and then close. So notice that I got this in the wrong spot. Somehow that ended up over there. Take that out. So target my box, target my LED, and then this closes the args, this closes the thread, and then this closes the arg, and then this closes the thread. I think we have to have that comma in there, in order for this to work. All right, so now I'm passing those arguments in. Let's see if this is going to run. Boom, look at that. LED is on, LED is off, LED is on, LED is off, and the box is closed. On, off, on, off. We did it. We did it. It worked. We passed the parameters into the thread. That is really cool. Now, I can't believe that I'm right that you got to put a closing comma there. Let's take that comma out, that trailing comma, and let's see if it'll run. No, you see it crashed the threads. Can you believe that? It crashed the threads. So I was right. You have to put, if you're only passing one argument, you have to put a comma. All right. If you're passing two arguments, you don't have to. And so, like, let's just say that I passed in here red and I passed in here the string blue. Okay, so I'm going to pass it two things, red and blue. Notice no trailing comma. And then I will read those in even though I'm not using them. And I'll just call it color. And then I will read it here as color. I'm not using those, but I'm just passing them to show you that if you have two arguments, you don't have to have a trailing comma. Okay, LED is on, LED is off. That's working. We're counting. Okay, so that is one of those crazy little things with the thread library, and I just wish I understood it better, because usually everything in Python is so logical and so clean and makes so much sense, but I don't understand why if you're just passing it one argument, you have to give it the argument and a comma. All right, now we saw how to do it with 0 arguments. We saw how to do it with one argument, and then with two arguments it kind of behaves in a logical way. And I hate being Mr. Postage Stamp down there. I like being life size, but it helps you see the code. Okay, guys, so I think that is pretty clear. Now, in a real program, what you would do is this first function might be like read the GPS, and then the second function might be like read the pressure sensor, and this one is up here constantly measuring the GPS device. This one would be measuring pressure. Now, in that case, what you have to do is you have to pass data out of your thread back to the main program. And the way you would do that is you would create a class. Okay, you would create a class, and then so you would create a class, and then you could just say you could just say self.gps, and then you could set that parameter, and down in the main program then you could read it. Go back and watch lesson 19 to remind yourself how to do classes. But the way you would have this thread running inside of a class, all right, and then you could get the data out pretty easily. And in the future, when we're doing more complicated programs, we'll kind of show you how to do that. But for right now, you know how threads work. So man, this has been a great set of lessons. You've learned the basic mathematical operators. You've learned if statements, while loops, for loops. You've learned how to pickle data, how to put data on a file, how to read data from a file. You have learned about functions. You've learned about methods. You've learned about classes, and you have learned about threads now. So you have got a pretty robust Python toolkit, and I think you know now enough about how Python works. If you wanted to do something that I didn't train you on, you could just sort of Google it and look and see some examples and understand how to do everything that Python can do, because I think you understand enough now that anything else you need to know, you would be able to learn it. Okay, so this is lesson number 20. This is going to wrap up the phase 1 of our Python lessons. The next phase, which would be like lesson number 21, but we're going to go back and we're going to start a new series, and it is going to be Visual Python, VPython. And what we're going to start doing is some very impressive three-dimensional renderings, three-dimensional graphics, some simulations. We're going to show you how to just create these really awesome three-dimensional simulations, three-dimensional visualizations. And so we're going to kind of get into 3D graphics. The good news is it's really easy, and the good news is with what you've learned now, you can really do the visualizations. Well, why would you want to do that? Well, maybe you want to hook your Python up to an Arduino and you want to be measuring temperature, but up on the screen you want to see a graphic of a thermometer, like a 3D graphic of a thermometer, and you want that thermometer adjusting to reflect what the real temperature is. So you can start building three-dimensional visuals to present a visualization of the data that you're taking in Python. So that's what we're going to do next. We're going to learn how to do the Visual Python. Then after that, we're going to learn how to hook your Python up to the outside world, like hook it up to Arduino, hook it up to Raspberry Pi, hook it up to another device, and then be getting real data into Python, which you can do things on. And then probably after that, we're going to learn how to do some graphing and start doing some like more data analysis stuff in Python. So I hope you guys are enjoying it. Hope you'll come back next week for the what would be like lesson number 21, but we will call it Visual Python lesson 1. Okay, guys, this is Paul McWhorter from TopTechBoy.com. If you enjoyed these lessons, be sure to give us a thumbs up. Be sure to subscribe to the channel and ring that bell so you'll get notifications when our new lessons come out. And if you like this, be sure to share it on your social media, because the world needs more coders, the world needs more engineers, and fewer people sitting around watching silly cat videos. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.